Bright Tuty. Every student matters.
Now let us see a few questions, numericals based on this wave equation. The first question: calculate the wavelength of a sound wave whose frequency is 220 Hertz. So, frequency is given to us in the question, taking us to be small f. This is given to be 220 Hertz, and speed is also given to us, which is equal to 440 meter per second. In a given medium, we have to find out the wavelength, which is represented by this lambda. This is what we need to calculate. Now, as per the wave equation, we know that velocity or speed is the product of wavelength and frequency. Velocity and the frequency is given to us, so the wavelength simply becomes velocity upon frequency. The value of speed or velocity is given to be 440 and the frequency is 220 Hertz. This will be equal to our wavelength, which comes out to be 2, and since the wavelength is expressed in terms of meter, so we will say that the wavelength of this sound wave will be equal to 2 meter. Right? Let us see the next question. A person is listening to a tone of 500 Hertz. So now once again Hertz, that means frequency is given to us in the question to be 500 Hertz. Sitting at a distance of 450 meter from the source of the sound. Now one quite important thing is, this is the distance of the person from the source of the sound. We are not actually talking about the wavelength, right? What is the time interval between successive compressions from the source? Now very importantly students, first of all we need to relate two things. One, we have to calculate what? Time interval. Second thing, between successive compressions. Now the successive compressions basically is the frequency, right? We have to calculate the time period, and we know that time period is simply the reciprocal of the frequency, right? So here I just place the value of frequency, that is 500 Hertz, and this comes out to be 0.002. What we are calculating is time period. So I'll take out to be second. So this will be the time period. Now very important thing students, this 450 meters is not to be confused. Just because it is given in the question, that doesn't mean that we have to take each and every value and we start thinking as to where this particular 450 value can be used. No. Simply try to relate what exactly we have to calculate in the question and then try to find out the way how to calculate it. Clear to everyone? Alright, good. Let us take another question. A sound wave has a frequency of 2 kilohertz. Now the frequency is given to us in kilohertz, and we know that the SI unit of frequency is hertz. So what we will do is, we will convert it into our SI unit, and kilo means 1000. So this comes out to be 2000 Hertz, right? And the wavelength is given to be 35 centimeter. The first very important thing while doing numericals in physics is to know what is given and to relate the units in which the values are given and in which the values should be given. So this is given in centimeter, and importantly the wavelength SI unit is meter. We need to convert it into meter. How? Just dividing it by 100, we can convert it into meters. This comes out to be 0.35 meter. Now, how long will it take? I need to calculate time period. This is what is required to travel a distance of 1.5 kilometers. The distance traveled is given to us, that is 1.5 kilometers. Again it is given in kilometers. I need to convert it into meters by multiplying it with 1000. So I will get 1500 meters. Clear? Now I need to calculate the time taken. How long will it take? So now I am given frequency, I am given the wavelength, and I need to calculate how long it will take to travel this much distance. So I am not calculating the time period. Actually, this is after reading the question, we relate that we are not calculating the time period. Right. So I can just remove this time period from here. Now this is quite important. After reading the whole question, we need to relate. We have to calculate the time taken by this particular wave to travel this much distance. We are not being asked time period, because had it been time period, I would have simply taken the way I have taken in the previous question. Time period is equal to 1 upon f. Then all these values which are given to us, it become redundant, useless. But we have to calculate how long the time taken by this wave to travel this much distance. And for calculating time, simply I know the formula that we have been using since the first chapter. Speed is equal to distance travelled upon time taken. Now time I need to calculate, distance I am provided with the value in the question. The important thing is to get speed. And how I am going to get speed in the case of a wave? Speed, I know the wave equation is given by the product of lambda, that is the wavelength, and the frequency. Both of the things are given to me in the question. The wavelength is given to be 0.35 meter and the frequency was given to be 2000 hertz. Got it? Fine. So this will be the speed. Calculating it, removing the decimal, I will just calculate, it will come out to be 700 meter per second. This is the speed. Now I can put the value of speed in this formula and I can relate that time taken by the wave will be equal to distance upon speed. Distance is given to me to be how much? 1500 meters. Speed is 700 meter per second. Cancelling these two zeros, I will get 15 by 7, or just calculating it further, I will get 2.1. What I am calculating? I am calculating the time, so the SI unit will be second. So now 2.1 second is the time taken by this particular wave of wavelength 2 kilohertz to travel a distance of 1.5 kilometers. Clear? Fine. So these are a few numericals based on wave equation, right? Now when we are talking about sound waves, there are a few characteristics of sound waves that we need to relate. Now what are those characteristics of sound waves? We will see the various characteristics of a sound wave. The characteristics of sound waves is, there are three characteristics that we will be studying about. The first question, let us relate. A person has a hearing range from 20 hertz to 20 kilohertz. Kilohertz means 20,000 hertz. What are the typical wavelengths of sound waves in air corresponding to these two frequencies? Taking the speed of sound in air to be 344 meter per second. So now we have been given the frequency range of humans. The frequency in the first case is the lower end, that is 20 Hertz, and the frequency in the upper end is 20,000 Hertz. The speed of sound is given to us is 344 meter per second. Same here, we are just simply required to calculate the wavelength. Now we know the wave equation. What did that wave equation say? The wave equation said that the speed or velocity of the wave is given by the formula wavelength multiply by the frequency. Speed is denoted by small v, wavelength by lambda, frequency by nu or small f. We have to calculate wavelength or lambda, which will be calculated by the formula the speed upon the frequency. Right? Now, in the first case, if I am calculating the lambda, let us be the wavelength of first part, that is 20 Hertz. The velocity or speed is 344 given to us, and the frequency is 20 Hertz. Therefore, the lower end wavelength frequency of 20 Hertz comes out to be 17.2 meters. Got it? Talking about the second part, we will calculate lambda here also with the same formula. It is equal to speed over frequency. The speed is same, 344 meter per second, and the frequency now is 20,000 Hertz. Right? So, calculating it, I'll get the value to be 0.0172 meter. This is the wavelength of the frequency range when the frequency is 20,000 Hertz. So, now we can relate that the wavelength of sound, which is corresponding to the frequency range of a person, that is 20 Hertz, the wavelength is 17.2 meters, 17.2 meters, and 20 kilohertz is 0.0172 meter. So, the wavelength range is from 0.0172 meter to 17.2 meter. Clear? The frequency of a source of sound, the frequency is given to us to be 100 Hertz. This is the frequency given to me. That is given to be 100 Hertz. How many times does it vibrate in a minute? Now, first of all, we need to relate what frequency is. Frequency is the number of vibrations per second. So, if frequency is 100 Hertz, that means that the number of vibrations or oscillations will be 100 in 1 second. So, if it is vibrating 100 times in 1 second, I need to calculate it in a minute, and I know that in a minute there are 60 seconds. Therefore, I can simply multiply by 60 and it will be equal to 6000 times it will vibrate in 1 minute. Clear? It is simple that we need to know what frequency is. Frequency is basically the number of oscillations per second. So, if frequency is 100 Hertz, that means the number of oscillations will be 100 times in 1 second, and if it is 100 times in 1 second, we need to calculate for 1 minute. 1 minute has 60 seconds, simply multiply it with 60, it will be 6000 times. That's it. Clear? Thank you so much.